Hello everyone, today we are going to discuss about the topic asymptotic notation, which is done by myself Ullas, Chinmay and Uttam. Now let's start about the introduction to asymptotic notation. Asymptotic notations are the mathematical tools used to describe the performance of an algorithm as the input size grows. They provide a high level understanding of how algorithm scale works, and they also help us to analyze about the different algorithms and to select as the which as the best case for workflow of an algorithm. Asymptotic notations play a vital role in computer science, particularly in algorithm analysis. Here, it tells about that asymptotic analysis simplifies complex problems by providing a clear framework for the user that tells that it is the best, worst and average case performances.
So basically the types of asymptotic notation are three. They are called as big O notation, big omega notation and theta notation.
The first type of the asymptotic notation is big O notation. Big O notation is used to describe the performance or complexity of an algorithm. Specifically, it describes about the worst case scenario with respect to the time or space complexity. The big O notation also describes about the asymptotic behavior of a function, not its exact value. The big O notation can be used to compare the efficiency of different algorithms or different data structures. Here, with respect to the diagram, in the x-axis we have n, which is also known as input size. In the y-axis we have t, which is also known as time complexity. Here we have here two functions f of n and g of n. To compare with the order, we have to write f of n is equal to order of g of n. The equation goes as follows: f of n is less than or equal to c of g of n. Here in this order we have to tell that f of n is less than or equal to c of g of n. So we have to make sure that c is always greater than 0, and we have to make sure that n0 value is also greater than or equal to 0, and at last we have to also make sure that n value is greater than n0, greater than or equal to n0. To consider big O notation or to understand it easily, let me give you an example. F of x, or also called time complexity of any algorithm with respect to anything, let us consider the equation as 2n square plus n. Here in big O notation we have to mention and note that the upper bound c star of j has to be always greater than f of n. In keeping this in mind, we have to write that f of n of order of g of n as written. We have to make sure that if f of n value is given 2n square plus n, it has to be less than or equal to c star of g of n of the order. Here we have to write the value such as in case it has to be greater than the f of n. With example, let us take 1. In case of 1, we have written as 1 square plus 1 less than or equal to c of n. If we consider here n, the c value has to be, if it total value has to be 3, it has to be greater than 4. 4 has to be greater than the 3. Here we have to make sure that the value of n is usually greater than, with respect to this, it has to be greater than f of n. The c value has to be 4, so that c value has to be 4, so that it equals to this f of x equation and it relates to the formula. By considering this, I would like to conclude that the big O notation is described as a worst case. Here in simple terms, f of n is equal to order of g of n. If f of n grows no faster than c star of g of n for all n values greater than or equal to n0, where c and n0 are constants.
So the second type of asymptotic notation is big omega notation. So the big omega notation is a way to express the asymptotic lower bound of an algorithm time complexity, since it analyzes the best case situation of an algorithm. So that it represents the asymptotic lower bound of an algorithm, and it is used to calculate the best case situation of an algorithm. It provides a lower limit on the time taken by an algorithm in terms of the size of an input. It denoted as a omega f of n, where f of n is a function that represents the number of operation in steps that an algorithm performs to solve the problems of a size of an n. There are given two functions g of n and f of n. We say that f of n is equal to omega of g of n if there exist constants c is greater than 0 and n naught is greater than or equal to 0, such that f of n is greater than or equal to c into g of n for all n is equal to n is greater than or equal to n naught. In simpler terms, f of n is omega g of n if f of n will always grow faster than c into g of n for all n is greater than or equal to n naught, where c and n naught are constants. So this is the graphical representation of a big omega notation. That the y-axis represents the time and the x-axis represents the input size. There are the two functions which is named f of n, which is a uppercase, and c into g of n, which is a lowercase. And this equation represents this graphical representation where f of n is equal to omega of g of n and f of n which is greater than or equal to c into g of n. And the big omega notation which helps us in the select in the best case of an algorithm.
Third type of asymptotic notation is theta notation. Theta notation is a mathematical notation used in analysis and design of algorithm to describe the average running time of an algorithm. It's also known as big theta notation. Coming to the graph, consider functions f and g from set of natural numbers. The function f is said to be theta of g if constants c1 and c2 are greater than 0. In theta notation, it's represented by equation. It's represented using equation. Function f of n should be greater than c1 of g of n and it should be lesser than c2 of g of n. For example, consider the value of function b 2n square plus n. We know that the value of c1 of g and also the g1 g of function value. We know that the value of c1 should be less than f of n and the value of c2 should be greater than function f of n. So here it will come 2 and here it will come 3. That's it. Now let us discuss about the applications of asymptotic notations. The first one is algorithm optimization. So its asymptotic notations help us to select the best algorithm at that situation from sorting to searching. That is, it guides the developer to select the best algorithm at that situation, which improves the performance and saves the time. Second application is data structure selection. So asymptotic notation will help us to select the perfect data structure, which improves the performance of the algorithm, efficiency of the algorithm, and accuracy of the algorithm. It helps us to take these workable decisions. Third application is performance benchmarking. In this competitive world, asymptotic notation will help us to frame a benchmark in algorithm. That is, it helps us to select the best algorithm in particular situation so that we can create a benchmark which improves our performance in this competitive field. With this, the topics have been covered that are given to us. So we'll conclude this video. Thank you.